That means here we have to prove that the altitudes of a triangle are concurrent. Concurrent means they pass through the same point. What is an altitude? Altitude is the length that is drawn from the vertex to the opposite side, making 90 degrees. This is a perpendicular line. Right. So this angle is 90, this is 90, this is 90, this is 90, this is 90, 90, this is 90. All three are vertices. All three are altitudes. Now, if all three are altitudes, we have to prove that they will meet at one point. Right. For this, what we do, let us draw two altitudes. Right. And whatever is the point, that is that is the meeting point. Let us say, for example, the triangle is ABC. Right. And the altitudes are D and D. Right. And these two are the original altitudes AD, and BE. So, and let them meet at some point called. Right. Now we'll try to prove whatever line that we draw through O and C connecting O and extending, then this angle will become 90 degrees. Right. Whatever line if we are drawing, that is also an altitude, we'll try to prove that. Rather than assuming that CO is altitude, we'll assume only AD and BE are altitudes. And whatever is the common point of this meeting point of AD and BE, if we draw some other line which is passing through this common point O and C, then that will also become an altitude. This is what we want to prove. Right. If we are able to prove that this angle is 90 degrees, then that automatically means all three lines are concurrent. Right. Now here this is altitude, that means this is 90 degrees, this is also 90 degrees, this is 90 degrees, this is 90 degrees. Right. Earlier, we have discussed that in a cyclic quadrilateral, opposite angles they together add up to 180 degrees in a cyclic quadrilateral. We also have another theorem which states if opposite angles are adding up to 180 degrees, then that quadrilateral has to be cyclic. Right. Here in this case, this angle and this angle are 90 degrees. That means sum of these two are 90 degrees. That means OECD is a cyclic quadrilateral. Right. We have another theorem which says that. What does it say? If sum of opposite angles is 180 degrees, then automatically we can draw circle through all the 4 points. Right. So now this angle and this angle is anyway 180 degrees, sum of this because both are right angles. Then remaining this and this is also equal to 180 degrees because in a quadrilateral the total is 360 degrees. Right. Now OECD, this is concyclic. That means we can draw we can draw a circle going through these 4 points. Some circle. Okay, you can draw some circle. Right. Now, similarly, this angle ADB, this angle and AEC, these are 90 degrees. Right. ADB and AEB. These are 90 degrees. What does and this triangle ABD is a right angle triangle. Similarly, ABE. This is also a right angle triangle. Right. This is also right angle triangle, and this is also right angle triangle. And AB is the common hypotenuse for both of these triangles. Right. ABE, the hypotenuse is AB. Right. Similarly, ADB, the hypotenuse is again AB. Right. So we already know that if any triangle will be able to draw a, a circle around any triangle, right? Now at the same time, this there are two right angle triangles. There are two right angle triangles, and can obviously draw circle around both of the right angle triangles. At the same time, because these are right angles, right? Angle in a semicircle is 90 degrees. Right, angle in a semicircle. So that means AB has to be hypotenuse, AB, which is the hypotenuse of both of this, should be the diameter of the circle, and this becomes a semicircle, right? This becomes a semicircle because angle in a semicircle. This is ADB, which is the angle in the semicircle. At the same time, AEB, which is also the angle in the semicircle. Both are 90 degrees. And because ABD and AEB both are triangles, in any triangle we should be able to draw a circle. And because it is a right angle triangle, the hypotenuse becomes the diameter. Right, it becomes the diameter and the radius is obviously half of the hypotenuse. We are not worried about the radius now. So now, what does that mean? AEDB. This is also conside. AEDB. That means if you are able to fit a semicircle, obviously that means we can put the remaining semicircle also. This that means these 4 points are also on a circle. Right. Let's take this circle 1. Let's assume this is circle 1 and this is circle 2. In the circle 1, let's take this arc DC, this arc, right? This arc. This arc is making some angle here, right? Let us assume this is alpha, right? This is on the circumference, right? Angle on the circumference. This arc, the same arc is making this angle, the same arc is making this angle, right? Basically DOC and DEC. This is O, this is O. So DOC, that is on this on circle 1. Circle 1 and this arc DC is making DOC and DEC on the circumference. Both are on the circumference, both by the same arc. So DOC should be equal to DEC, which is again alpha. Right. Both are alphas. This angle is alpha. Right. Now at the same time, if this is alpha, then if you take these two lines, they are like this, right? So this becomes again alpha. This becomes again alpha. This is a, let's say the point we are talking about. FOA. FOA is also equals alpha. If this is alpha, this is alpha. FOA should be equal to this because these are opposite angles of the same two lines, right? This is alpha, this is also alpha. Now, again, let's take this circle. Circle number 2. Circle number 2. Now, in this circle 2, let's take this arc BD. BD is making BAD, this one angle, right? And BED, again on the same circle, right? BED and BAD, right? These both are on the circumference. If this is beta, this also should be equal to beta, right? This also should be equal to beta because both are made by the same arc and on the same circumference. Right. Let us quickly the diagram has become little clumsy. What we are trying to say, what we are trying to say is if we connect D and E and then this is O, then this is alpha, then this is also alpha, then this is also alpha, and BD is making, so this is beta, then BOD, this is also beta, right? Basically, what does it mean? BOBED, this is beta, and DEC, this is alpha. But beta plus alpha is equals 90 degrees, right? Because BD, we have assumed BE is actually an altitude, right? So this angle is 90 degrees, this angle is also 80 degrees. Alpha plus beta is actually 90 degrees, right? What does that mean? This alpha plus this beta is also 90 degrees, right? What does that mean? This angle must be a right angle, right? Because AFO in this triangle, two of the angles together are making 90 degrees. That means the third angle should be 90 degrees, which is what we wanted to prove. Now, this angle, this CF is making 90 degrees. Right? CF is what? CF is a random line that is drawn through the point. Right. Initially, we didn't know that it can make 90 degrees. But because of these two cyclic quadrilaterals and because of these circles, we have proved that alpha plus beta is also 90 degrees. Right, yes. So that's what that means. The three lines that are passing through this point are actually perpendicular. Two of them are anyway perpendicular. The third one is also perpendicular to the side. That means all altitudes of a triangular component. Right, guys? Thank you.